Hi everybody, and welcome to tonight's video where we're going to be talking about slope. For some of you this might be a review, but we're going to address this just like we've never seen it before. So the first thing we're going to talk about is definition, and then we'll talk about a couple methods for determining the slope of a line. So first of all, what is the slope? The slope of a line is the ratio of the vertical rise of the line compared to the horizontal run of the line. So whenever I see the word ratio, I think fraction. So this is going to be a fraction. And when we're comparing a ratio of two different quantities, the first quantity is going to be the numerator. So the vertical rise will be my numerator here. And the horizontal run will be the denominator of this fraction. And so when I'm comparing that, the vertical rise, another way to say that is going to be the change in the y coordinates or along the y-axis, or change in y. And then the horizontal run, when we think about the way that a horizontal change occurs, that's going to be the change in the x coordinates, right? So change in y over change in x is one way you'll see this written. Rise over run, those are the other two terms that you'll hear sometimes. So either way, this will be a fraction where you have the change in y, or the rise, over the change in x, which is the run. Okay, and there's two ways that we can determine the slope of a line. You can look at 2 points on a line and determine how you go from one to the other, or you can use a little formula that we're going to develop where you have the coordinates of 2 points on a line. So let's look at the first method, method 1. When we're trying to use 2 points on this line, whenever we read a line, it's just like reading a sentence. So we're describing the change as we're moving from left to right along this line, right? So if I pick a point here, I'm moving from left to right. So the next point that I pick to determine the change has to be somewhere over here, right? So I don't pick this point and then move that way, right? We're always moving left to right, just like reading a sentence. So when I'm describing the change, again, we're using rise over run. So we should have a fraction, rise over run. Now, if I'm moving up from one point to the other, that's going to be a positive number. If I move down, that's a negative number. If I move to the left, right, to get to the next point or something like that, if I'm reading, if I'm going in the opposite direction, use a negative number. And as I move right, I'm sorry, that's not right, that's down. As I move right, I would use a positive number there, right? So like we said, generally speaking, we always try to read this from left to right. That way we'll get our negative sign either from the numerator or from moving up or from moving down. So in this case, how far do I have to move up, and then how far do I have to move over to get to that line? So I am moving up 1, 2, 3 units. So that's plus 3. That's my rise. So my rise equals plus 3. And so then my run, now to move, how far do I have to move over? That's going to be plus 3, because I had to move in the right 3 units, right? So I had to move up 3 and over 3 to get from this point of the line to this point of the line. So my rise over run equals plus 3 over plus 3, and I would simplify that. Positive over positive is positive number. 3 over 3 is 1. So in this case, my slope is positive 1, right? So we originally write it as a fraction, as plus 3 over plus 3 to represent our rise over run, and then we simplify that fraction. So even though when we're determining slope, we are always going to start with comparing this rise over run as a fraction, our final result for the slope doesn't necessarily have to look like a fraction, right? This is still a ratio, a rational number, right? 3 over 3, but our final answer for the slope in this case would be 1. Okay, so try to copy this down in your notes, this blue line here, and I want you to try to determine the slope of that on your own. And so you can pause the video here and then see if you can determine the slope, and then we'll come back and answer it together. Okay, so if you pause the video and you drew this line in yourself, hopefully you recognize that the slope of this is a little bit different than our line before. And when you're picking 2 points to determine the slope on the line, what's the most convenient is to always pick the points of coordinates that you can clearly determine. So like right here, for example, I would pick this point and this point because those hit the grid at clear points that I can determine their coordinate. Right here, like if I start halfway in between, that might be a little harder to determine how to go down or left to right, that sort of thing. So right here, to get down to this next point, I go down 1, so my rise is -1, and then I move over to the right 3, so my run is +3. So rise is -1, run is +3. So to determine the slope here, we get rise over run, and that's -1 over +3, and so I would just simplify that as -1/3. So that's my slope in this case. So slope equals -1/3. All right, so that's one way to do it. You just basically draw dotted lines to determine how to go from one point to the other. Use nice points that are at convenient locations, and you just compare your rise over run. Method number 2, maybe we're not given a picture. But if we are given 2 points and their coordinates, then we can determine the slope of that line. So we have a formula that helps us determine slope. Slope, you're going to see this written as m, right? M is the variable that we usually use to represent slope. So sometimes whenever you see the word or the letter m, you're going to think that that is going to represent slope when we're talking about the equation of a line. So our equation, our formula, is m equals y2 minus y1 over x2 minus x sub 1, right? These are subscripts, right? Because they're not exponents, they're subscripts. They're written a little bit below the letter. And in this case, we are using this y2, y1, and x2, x1, where those are the coordinates of different points. So x1, y1, and x2, y2 are the coordinates of 2 points on the line. Okay, so on the line that we want to determine the slope of. So x1, y1, those are the coordinates of our first point, and x2, y2 are the coordinates of our second point. Okay, so those are the 2 points, and so we're just going to be plugging numbers into this formula right here. So we've done something similar like this when we did like midpoint formula, distance formula, that sort of thing. So we should be familiar with determining these points and just plugging them in. So if I wanted to, for example, find the slope of the line that passes through or passing through, and now we'll have 2 points. Let's say -2, 10 and -4, 16. Okay, so let's say we have some line that passes through those 2 points. So what we're going to do here is identify this as x1 and y1 because that's the first point. This is x2 and y2, that's the second point. And now we're just going to plug it into our formula. Now remember, slope represents the vertical change over the horizontal change, the rise over run. And remember, y is our difference in up and down, vertical change, and x represents our difference in horizontal change. That's why it's y2 minus y1 and x2 minus x1. And the reason it's minus, right? Minus, remember when we're doing subtraction, we call the result of that a difference. And remember, difference is another word we can use for change. So the difference between something or the change between something. So that's why we're using subtraction. So those are some little helpful hints you might want to write down onto the side as to how to remember this formula. Okay, So m equals y2 minus y1, 16 minus 10 over x2 minus x1. So remember, x1 is a negative number, we're subtracting it, so make sure you put that in parentheses so you don't lose that negative sign in front of the 2. So 16 minus 10, 16 minus 10 is 6, and then we have negative 4, so you could rewrite this if you want. First step, always write it in parentheses. Second step, simplify, so it's minus negative, that's really plus 2. So I have 6 over negative 4 plus 2, which would be negative 2. And so 6 over negative 2 gives us negative 3. Okay, so our slope for this line that would be passing through those points is negative 3. And so negative 3 means it's decreasing. And we'll talk a little bit more about that in class tomorrow, about what the sign of the slope tells us about how the line looks. And the last thing that we're going to talk about today in our video are just three facts, really, or 2 facts, I'm sorry, about the slopes of 2 lines. So if I have 2 lines and I know their slopes, then I can identify a special relationship between the lines. So number 1, if 2 lines have the same slope, then those 2 lines are parallel, right? Because they'll be changing in the same way from left to right, and so they'll never cross because their slopes are always going to be the same and they're always going to run parallel to each other. Then, if we have 2 lines that have slopes that are opposite, which means they have different signs, where one's positive and one is negative, or one's negative, the other one's positive. If they are opposite reciprocals, which means we flip the numerator and denominator, then those lines are what we call perpendicular. Remember, perpendicular means they meet at a right angle, right? So they would look something like this. Okay, so remember, if I had something that was an opposite reciprocal, so let's say the slope is 2/3. If that's the slope of one line, the perpendicular slope, right, so I'll use that little symbol for perpendicular slope, would be the opposite reciprocal, so it's going to be negative, and then it's going to flip this fraction, so negative 3/2. So if I have one line that has a slope of 2/3, the slope of the line that's perpendicular to it is negative 3/2. Okay, so those are some facts that we'll talk about tomorrow in detail in class. So bring your notes for all of this about slope, all this information about slope to class tomorrow. We'll start with some little review examples, and then we'll do some practice problems in class. I'll see you then. Have a great night.